Okay, number 56 is another definite integral. Now this problem, you need to know that the antiderivative of secant tangent is secant. Although technically you could convert this into sines and cosines and use substitution, but it would be just so much easier if you knew that it was secant. So the antiderivative of positive secant is positive sec, so it's 9 sec. Plug in the upper and the lower, and secant's 1 over cosine, so at 3 pi over 4 you have 1 over the negative root 2 over 2. At negative pi over 4 you have 1 over positive root 2 over 2. So those flip over, and then 2 divided by square root of 2 equals square root of 2. So you have 9 times negative root 2 minus a root 2, which is negative 2 root 2. And 9 times negative 2 root 2 would be negative 18 root 2. So that would be the correct answer. Now this one we're going to find the average value over a given interval. And always be aware how to find setting the function equal to the average value, although this would not be a problem that I would use that on, where you have to find f of c, where f of c equals this result. But this one's not as good an example with this trig function, but it's perfectly fine for finding the average value. So the average value is, now I didn't indicate it here, but right at it. But anyway, let's just do the antiderivative 8 sine of x from 0 to pi, which the antiderivative sine of x is negative cosine of x. And then I use that same property I used earlier. If you flip around the 0 and the pi, that will just change the negative 8 to positive 8. So cosine of 0 is 1. Cosine of pi is negative 1. So 1 minus a minus 1 is 2. 8 times 2 is 16. But the average value is this integral, the formula which is given on a formula sheet for you. It's this integral divided by b minus a. So that's where the pi minus 0 comes right here. So you take the result of that definite integral and divide it by pi minus 0, so it's 16 divided by pi. Now the second fundamental theorem of calculus. So we're finding the derivative of the integral, which sometimes on the third exam, this gives people lots of fits here, but it's because they make it more complicated than it really is. Because the key thing to remember here is you're not integrating anything in this problem. Now you are taking a derivative, but the second fundamental theorem of calculus basically boils down to the derivative of the integral. What you're doing is you're taking this upper limit. You don't have to worry about the 0 down here. You take the upper limit, you plug the x to the 6 in for t, and then you take the derivative of that x to the 6. So if that was just x and not x to the 6, you would just plug the x in, and the answer would just be cosine of x, and it'd be over. But here, see, I wrote that as dy dx. Sometimes, the book uses, like, I think capital F for this or something, so it'd be f prime or whatever, but this is sufficient. So all you do is put the x6 in there, so it'd be cosine square root of x to the 6, but then you must remember to take the derivative of that upper limit, x to the 6. So the square root of x to the 6 is x third, and then the derivative of x to the 6th is 6x to the 5th, so I'll just put that in front. So you have 6x to the 5th cosine x cubed, and that's all there is to it. So in this kind of problem, if you if you're trying to do any kind of integration, you're definitely doing it the wrong way. So number 59, this integral will require substitution. You let u equal what's on the inside of the parentheses here, which is 8t plus 4, which you see I went ahead and just brought up the exponent for the t. Take the derivative of that, which would be negative 8t, negative 2 dx. Now I left out a step, which I guess I could have shown, but I'll go ahead and just say it verbally. Then you could divide both sides by -8, so you'd have -1/8. That's where this -1/8 is coming from right there. Is -1/8 du equals, oh, well, huh, I guess minor mistake here, but I guess that should be variable t and not x. But anyway, so then you would have t to the -2 dt equals -1/8 du. So that means then, so that 1 over t squared on the outside that you have, or the outside in front of the sign, you would, that would represent your du. -1 over 8 du would be that. Try and do this without using a tablet. I don't have a tablet right now, but I think I'll just try to copy this piece and then, all right. So that's where the -1/8 is coming from. And so you have -1/8 sine of u du. The antiderivative of sine of u is negative cosine. But you see, so you have a negative already out here, though, so therefore, even if you put the negative here, you still have the negatives. The two negatives would then cancel each other. So you end up with just 1/8, positive 1/8 of cosine of u equals 1 over 8 cosine of, and then u, which is the 8 over t plus 4, then plus c. So it's answer D. So careful that you don't pick answer B where it has the -1 over 8, because that's not correct. Okay, let's see what we have now. Number 60. You let u be what's in the parentheses, 3 plus cosine of t, which makes du be negative sine of t dt. So you just move the negative over, and there you have your numerator perfectly. So I'll put the negative on the outside. So I went ahead and brought this up so you can see that. So the negative goes on the outside. So now you just have u to the -3. At some point you were going to have to bring it up anyway to use the power rule. So the negative's on the outside, u to the -3 du. So you have that negative there. And it's, do the power rule, -3 plus 1 is -2. Over -3 plus 1 is -2. And the two negatives cancel, so then bring the u down. You have 1 over 2u squared, and the u was 3 plus cos t, so you have 1 over 2 times 3 plus cos t squared, and that would match answer A. '61. Substitution, where you let u be x to the 6th plus 7th. So that makes du equals 6x to the 5th dx. So once again, I didn't show the 1/6, but you divide both sides by 6. So 1/6 du would equal x to the 5th dx. And so then the square root would just be represented by u to the 1/2 power. So you have the 1/6 right here. You have u to the 1/2, and x to the 5th dx comes from the du. And 1/6 u to the 1/2, just do the power rule, so you'll end up with 2/3 u to the 3/2. And 1/6 times 2/3 ends up being 1/9. So you have 1/9 x to the 6 plus 7 to the 3/2 plus c. All right, so that's a nice straightforward substitution. This one it's a definite integral. So you let u equal x squared plus 1, which means du would be 2x dx. So we have an x dx right there. So once again, divide by 2. So that produces the 1/2 right there. So so what I did here is, because I wanted to change this to u, you might as well change the limits of integration to u. That way you never have to go back to x again. So sometimes people will mess this up. They'll use u and then not change the limits or vice versa. But if you put 1 in here, x squared plus 1, 1 squared plus 1 is 2, 0 squared plus 1 is 1. So now I have 1/2 from 1 to 2, new limits, u to the 5th du, never have to go back to x again. So the antiderivative of u to the 5th would be 1/6 u to the 6th. And the 1/2's there, so you have 1/12. Put 2 in there, you got 2 to the 6th, minus 1 to the 6th. You end up with 63 inside here, so it's 63 over 12, and that reduces to 21 over 4. So that would be the correct answer. 63. U equals 3 plus cotangent theta. And take the derivative of that. That's going to give you cosecant squared, so that's negative cosecant squared. So it's kind of important to know that. That makes it a little easier. Although you could have made it more complicated. It would have worked if you distributed it anyway. Let's not go into that. Let's do it the most direct way possible. So 3 plus cotangent theta, the derivative is negative cosecant squared, so I have to move the negative to the outside. So the negative's here. And really, so that's not raised to any power other than 1, so it's just u du. But you see I changed the limits of integration. So you put 3 pi over 4 in there. And cotangent's 1 over tangent, so you end up with 3 plus 1 over negative 1, which is 2. 3 plus 1 over positive 1, which is 4. So your integral basically reduces to negative from 4 to 2 u du. I have to use that property again, flipped it around, 2 to 4. So the antiderivative of u will be 1/2 u squared. Plug in 2, plug in 4, plug in 2, subtract, and you'll end up 1/2 of 12, which equals 6, which is answer A. 64. We use log properties to split this up before we take the derivative. Let's see. So let's see what we have. So it's natural log of 1 minus x minus natural log of x plus 2 to the 4th. And then using log properties, because the log's not raised to the power, the argument is you can bring that 4 down. Now, then you take the derivative. So the derivative of 1 minus x would be negative 1 over 1 minus x. And then the derivative of x plus 2 would be 1 over x plus 2. I'm not a big fan of having to force you to combine these into one fraction. I'd probably leave it as split up fractions on a test. But I'll go ahead and, I went ahead and did it just to show you. But I would have been happy, with just negative 1 over 1 minus x minus 4 over x plus 2. And that's the answer. I would have been happy with that, because that is the derivative. But I went ahead and got a common denominator just to show you that that was correct. So I merged those together, combined the numerator, and I got to be careful because this is a negative. So when you have negative times 4 minus 1 minus x, you'll have negative 4 plus 4x. So you combine all that mess, you'll get 3x minus 6, and x plus 2 over 1 minus x is the common denominator, and then combine all that, and then it matches answer B perfectly. (65) The derivative. The derivative of natural log of u basically is u prime over u, which is kind of a weird function because natural log is also the primary function, but it's also the argument. So essentially that whole thing is your u, ln of 8x. So basically it's the derivative of ln of 8x divided by ln of 8x. So the derivative of ln of 8x would just be the derivative of 8x, which is 8, divided by 8x, which that just reduces to 1 over x. But just to make it match that answer, it's not mathematically wrong to leave it as 1 over x on top and then ln of 8x on the bottom. But to match that answer, I dropped this x right here down to the bottom right there, and the 8's cancel, so it reduces to 1 over x, ln of 8x. Now, number 66. I broke it up as two separate pieces. I didn't really have to. Yeah, you see down here, the bottom way might be the more logical way to do it for you as a student, but I'll start with that. So basically, it's just the derivative of 5x squared over 5x squared. So it's 10x over 5x squared, which is 2 over x. But here I broke it up using log properties. ln of 5 plus ln of x squared, which makes it 2 ln of x. The derivative of ln of 5 would be 0 because there's no variable there. You know, ln of 5 is just a number, a constant. But the derivative of ln of x is 1 over x, so it would be 2 times 1 over x. So 0 plus 2 over x equals 2 over x. I think probably the bottom way makes more sense. In fact, I'm going to reverse the order. I have the solution of this. There we go. So that way it kind of implies the top way probably would have been the better way to go.